Good morning students. Myself Badi Alekhya, Assistant Professor, Department of Artificial Intelligence and Machine Learning, Rmd Engineering College. So in the previous section, we have discussed that minimax algorithm. So to overcome the limitations of min-max algorithm, I already insist to you guys, we are using alpha beta pruning. So in this today's session, we have discussed the problem of alpha beta pruning algorithm. So and also I will tell what's the advantages of pruning technique in alpha beta when you are going to solve the problem under min max algorithm for 2-player games. So let us see. So general definition is the modified version of minimax algorithm. So also we call it as an optimization technique of min-max algorithm. So what is the difference between that algorithm and what's innovation, what's the modification we did under min-max algorithm? Here we are going to eliminate the nodes which are not giving sufficient information. So the main advantages of alpha beta pruning here is we are going to cut the tree which are not giving the significant informations needed for the gaming. So the cutting the tree, game tree, which are not giving the significant information, technically we call it as pruning. So that's why we named the technique min max. We are using alpha beta. For that alpha beta we are going to applying the pruning techniques. That's why we name this algorithm as alpha beta pruning or alpha beta algorithms. Let us proceed with the terminologies already we heard in the min max algorithm. Alpha, which representing maximum value, that is indicated by the default value minus infinity, and beta, which is representing the minimum value. The initial value of beta is represented by plus infinity. So standard min-max algorithm only with some modifications. How we are going to improve the performance of 2-player games by using alpha beta pruning, let us discuss with one problem. So before going to solve the problems, just note it down what are the conditions you have to aware for solving the problem under alpha beta pruning. So the main condition you have to know where you are going to apply your pruning is when the value of alpha is greater than or equal to beta, then at that condition you have to prune your tree. Prune means is cutting your trees, subtrees. And what are the key points you have to remember when you are performing alpha beta pruning? Note it down. At max player you only update the value of alpha. Everybody aware of that. At maximum level, which value only we are updating? Maximum value. At minimum we are going to update the value of beta, because alpha representing the maximizer value and beta representing the minimizer value. So under alpha beta pruning technique, maximum level we are updating only alpha value, and minimum level we are going to update only beta value. So these two important key points. And after, when we are performing the backtracking in the tree, the node value only will be passed to the upper nodes instead of alpha beta. So I will show it in the problem how it is passing the node value to the upper nodes when they are applying the backtracking under alpha beta pruning. So where you can pass these alpha beta values means child nodes. So these 2 points has a clear confusion, you get a little bit confusion. Don't confuse, I will explain clearly. When you are going to apply backtracking only, you have to consider node values, but when you are going to apply the values to the child nodes, you can consider the alpha beta value. So I will explain when we are solving the problem. We will see when we are going to apply it to the child nodes, how we are copying the value of alpha and beta to the child nodes. When we are going to apply the backtracking, how we are going to copy the node values to the upper nodes. So in the problem we will discuss. So I directly move to the problem. So it is a problem. Initially the value of alpha is minus infinity, that is the maximum value. The value of beta is plus infinity. Again terminal node, maximum level, minimum level, maximum level. Put it in your mind. If you are aware of min max algorithm only, you can understand alpha beta pruning. So if you are seeing this video, before watching the video min max algorithm, just watch the video of min max algorithm first and then come to this alpha beta pruning. So if you observed here in this diagram, what are the terminal nodes present here? So what is the first condition of alpha beta pruning? This is the node. If you want to copy the values from node to the child nodes, which values you can copy? You can copy the values of alpha and beta. So min max algorithms follows which algorithm? Depth first search. At that time it's concentrate on which path first? Left side path. So now the node A, alpha value is minus infinity, beta value is infinity, means the children of A is B. The children of A is B. The left children, first in depth first search we completed the left part and then only we can move to the right path. So if A is the parent, if B is the child node, what is our condition? We can pass alpha beta values to the child node. So now what is the value of B? B is alpha equal to minus infinity, beta equal to infinity. What is the children of D? B, it is D. Again alpha of equal to minus infinity, beta equal to infinity. So now let us start that. Initially we are copying the values of parent node to the child nodes. The initial values of the parent node to the child node is alpha equal to minus infinity, beta equal to infinity. So I will move to the diagram and I explain that what is step 2 and step 3. Same like that, if you observed here, what is the initial value of alpha? Minus infinity. Initial value of beta? Infinity. At maximizer level, this maximizer level, at maximizer level, which value have to update? Alpha value only. Initially what is the value of alpha? Minus infinity. I am going to check minus infinity with 2 and then I am checking 2 with 3. If I am going to check minus infinity with 2, what is the maximum value? 2. Again I backtrack. If I backtrack, I am going to check among 2 and 3, which one is the maximum value? 3. That value I am going to update to the alpha, because alpha is the maximizer value. Now we are at which level? Maximum level. Then you have to consider the maximum value. Then I am going to apply the backtracking at my step 3. I slowly explain. Initially the value of alpha is minus infinity. We are at maximum level. I am going to consider the maximum value. First I am checking minus infinity with 2. 2 is the maximum. And then 2 I am going to check with 3. Then among these two, which one is the maximum? 3 is the maximum. Now I can replace the value of alpha with 3. How the value of D will be 3 na? I insist to you guys what is the previous point here. While backtracking, when you are going to apply backtracking, the node values will be passed to the upper node. Now we will move. What is the upper node here? B is the upper node. What is the node value of D? 3. So these node value will pass to the upper node. What is the value of B now? The node B value is 3. Now we are going to move to the don't forget we are following DFS. So after completing this part only we can move to this part. Now we are at minimum level. So minimum level, which value only we will change? What is your point? The mean player will only update the value of beta. The mean player will only update the value of beta means go here. The mean value will only update the value of beta. In which way it is going to update the value of beta means among these things. So I have to move. I am not going to finalize the alpha value and beta value here. So alpha equal to minus infinity and beta value. So among 3 there is no value is present. If I am going to compare infinity with 3, which one is the minimum value? 3 is the minimum value. Therefore I am updating the value of beta equal to 3. I am comparing infinity with 3. Infinity 3 with 3 I am comparing the value of minimum value of infinity with 3 we consider it as 3 only. So again I am going to come here. I am going to check now it is at which level? Maximum level. So from parent to child, alpha equal to minus infinity, beta equal to plus infinity. So alpha equal to minus infinity, beta equal to plus infinity. It's going to copy the values of alpha and beta here. I am going to check with the values. I will explain here. I am going to explain this step 4 to you guys. Then it will be clear for you guys. So up to now you are clearing that alpha equal to minus infinity, beta equal to 3. The node value is 3. So this is the parent. The last condition, the parent node values, the parent alpha value, beta value will pass to the child node. So if you are going to pass alpha value and beta value, now initially what is the value of alpha equal to minus infinity, beta equal to 3 only. So I am going to move to the left node. Then alpha, I am going to compare minus infinity with 5. What is the maximum value? 5 is the maximum value. So here only we are going to check the condition. What's the condition we have to check? Initially I told one conditions to you guys. Alpha is greater than or equal to beta means you have to prune the tree. Here alpha is 5, beta is 3. The value of 5 is greater than 3. That's why I am going to prune this tree. So I no need to visit. This node is not significant for me in traversing. So let us continue. You can clearly understand if I move to the next step. So practice. So after listening you have to practice one time based on conditions means it's clearly understandable to you guys. So I will explain directly with the problem. So here 5 is there, here 3 is there, and again I backtrack here. After backtracking, you people knows that the node value will be passed to the upper node. When the node, what is the node value? So 3 is there, it will be passed to the upper node. What is the initial value here? We are not going to conclude that. You imagine that alpha equal to minus infinity, beta equal to infinity, because it is at maximum level. At finally only I will conclude the node values of this. I am going to copy that things. What is the rule of copying? I expecting answer. What is the rule of copying? From parent node to the child node, if I perform copy, I can copy alpha value and beta value to the child nodes. What is the alpha value here? 3. What is the beta value here? Infinity. So again, among this thing I have to give importance to the left node. Same thing, it is the parent node, it is the child node. As it is copying alpha equal to 3, beta equal to infinity. But and you are coming to the F. After that there is no child nodes, there are terminal nodes. Now we are going to apply the condition. F is at which level? Maximum level. So under maximum level, what is the condition? Alpha equal to minus infinity. That means I am going to check with minus infinity with 0. 0 is the maximum. Again 0 with 1. I am going to get the maximum value is 1, because we are at the maximum level. So this one clear? Up to this diagram, the as it is value of alpha and beta is copied to the child nodes in this direction. After copying the alpha and beta values to the child node, last terminal nodes is there. Again we have condition backtracking. Maximum level is there. For maximum level, among these two things, which one is the maximum? If I am going to compare minus infinity with 0, 0 is the maximum. Again 0 with 1, 1 is the maximum. So in the next diagram I will explain how the pruning will be performed in this thing. See, what is the node value of F here? 1. So now I am going to change the value here. That means I am going to apply the move to the backtracking. Backtracking, what it will do? The node value are going to pass to the C, but alpha value and beta value, alpha is 3, it's a constant. We are not going to change the value of alpha here, but we are going to change the checking. We are going to check the value of beta. So minimum value we have to consider. So what is the minimum value? We have 1 here. So that minimum value we are going to get in these things, and remaining things I am going to check that whether the alpha, what is the conditions to prune the tree? Alpha is greater than or equal to beta. So if alpha is greater than or equal to beta, yes, is it right? Yes, 3 is greater than 1, then no need to visit this entire subtree. We can prune this entire subtree, and after we are providing the conclusion that among these two things which one is the maximum. So maximum level we are going to concentrate on alpha value only. We are going to pass that values to the alpha. I will show the entire tree to you here. The maximum value, it is the minimum level. Among these two things, minimum value for the node, that means copying the node values to the upper nodes. 1 is here. Copying the node values to the upper nodes, 3 is here. Among 3 and 1, which one is maximum? 3 is the maximum. So our final conclusion, who will win the game? So alpha maximizer will win the game. If I am getting 1 here, means who will win the game? Minimizer will win the game. That's all. I will explain the condition here again for your sake. So you should be careful here. The 8th condition, after returning the node value 1 to the C, alpha equal to 3 and beta equal to plus 1, it will change. So at minimizer, which value we can change? We can change the value of beta. When you are going to change the value of beta, the beta value will be changed to 1, and again I am going to compare that the alpha value with the beta value. So 3 is greater than 1, then only we are going to perform pruning and we are going to cut this subtree. So thank you students, that's all for the today's session. I think so you clearly understand the concept of mean max algorithm and the extension, a modified version of mean max algorithm, that is alpha beta pruning. So the main important thing you have to remember under this concept is, for studies the conditions properly, key conditions needed to solve this problem, and apply the pruning techniques in the correct manner by applying the conditional probability, that is alpha is greater than or equal to b. So then it will be easy for you when you are solving the problems. Thank you students. We will meet with some other new concepts in the next sessions.